So let's derive the formula for distance and time to stop. Those who are not interested in driving, please skip and then directly go to the formula. But those who are interested, please stick to this. So I again came back to the basic, which is we already familiar with. The total traction force is going to be equal to all the resistance force which is acting on the vehicle. And the next what I did, I converted this traction force into the formula, which is torque of the wheel divided by radius, and I put the formula for all the resistance force which is acting on the vehicle. Now this is interesting part. Since we took the motor out of the vehicle or out of the equation, motor is no longer delivering any torque, and hence this torque has to be 0, and that's what you see. The left side, the term became 0 here. Since we are driving my vehicle now on the flat road, and hence I took the theta is equal to 0, and that's what this entire term became a short, which I have written here. And the rest, all the term remains the same, just I converted this acceleration into dv upon dt, and after rearranging the term, you will be end up here this term. What is this term? So dv upon dt is equal to minus b1 minus a v square. This is another constant, which is b1 equal to rolling resistance of the vehicle multiplied by the acceleration due to gravity, and the a we are already familiar with, which is equal to 1 by 2m into density into frontal area into drag coefficient. Now let's go forward. So what I did, I just rearranged this term, and then I wrote it in terms of dt is equal to dv upon b1 plus av square, and I put both side integration and I put the limit. So at t is equal to 0, the vehicle velocity is v naught. In our example, it is a 40 kmph. At time t is equal to t, the vehicle speed, let's assume it's going to be vt. Final speed is going to be definitely a 0. So the next thing what I did, I rearranged again this term, and I took the a out and I put in this format. Why? To utilize this formula for our integration here. So to use this formula to integrate, and then finally I wrote t is equal to 1 by a into 1 by root over b1 by a into tan inverse v by root over b1 by a, which is nothing but I'm using this formula, and then I put the limit v0 to vt. Let's go forward. So finally, if we put the limit, we will be end up with this entire term. And here if you see, there are a lot of a bunch of constant, and we can simplify this entire expression at least to look visually good. So what I did next, I took this as another constant which I defined as a d, which is here I have written, and then this entire term tan inverse into v naught into root over a by b1, I took it another constant which I defined as a c, and then this root over a by b1, I took it another constant and defined as a p here. So if you see in the next step, the t is just equal to 1 by d into c minus tan inverse vt into p, and the respective constant we can take it from this formula. So now this is at least visually, I would say, the best. So next what I did, I went ahead and then I rearranged in term, and then found the speed of the vehicle in terms of time here. So speed of the vehicle will be 1 by p into tan c minus t into d. Now I need to define a distance in terms of time t. So we can write this v as a ds upon dt, and then we can integrate both sides, and if we use what I call this formula for our integration, we will and put the limit appropriately, then we will end up here. So congratulations to you, we have found the formula for time as well as the distance. What is formula for distance? Is 1 by a into natural log cos of c minus td divided by cos c. What is c? We can refer here. What is d? Which is nothing but root over a into b1. What is b1? We can check it here. And what is a? We can check it here. And then what is, yeah, rest thing we know it here. So this is, finally we found the formula for time as well as distance. So but I am interested in time to stop. When this v will become 0, then it will be just c by d. And what is the distance when t is equal to c by d, and I end up this formula, which is 1 by a into ln 1 by cos c, or this you can also write as a minus 1 by a into ln cos c. So finally we are done with the derivation of the formula. Now let's go back to the Excel sheet and see what results that we are getting out of this formula.